Welcome to Maths for All. I'm Aisling Flynn. This is Functions 1.1 and we'll begin with an example. An electrician bills his customer per hour that he works. His bill is a function of time, so it's something that changes with time. The outcome or resulting bill depends on the time worked. So some details. An electrician charges €15 per hour of work. He worked at one house for 3 hours. What is his bill? So that's 3 hours at €15 per work. So 15 times 3 gives 45. Can we write a general expression that applies to all his bills? Well, yes, we can. Okay. And let's just explain some of the notation. So where B is the bill function. Okay, so here's our function. Our function is B, and B changes depending on T, time. Okay, how do you calculate the B? You do 15 multiplied by T, which is the time. So this is our variable, what changes. Okay. Let's try elaborate on that a small bit. So typically though, an electrician will charge a call-out fee to review the job before commencing any work. So this electrician charges a €50 call-out charge and €20 per hour of work. He worked at one house for 2 hours. What is his bill? So what would it be? It would be €20 for 2 hours, but also add 50 for his call-out charge. So his bill would be €90. Can we write a general expression that applies to all his bills? Okay, again we're using function notation now. The bill here, B, is a function of time. It changes with time. Okay, and for this electrician it's €20 for every hour, so it'll be 20 times how many hours? So T is still the variable, still what changes, plus 50, so 50 would be a constant in each of the calculations. So B is the bill function and T is the number of hours. So this is just a couple of examples to show you the function notation. So functions. What is a function? A function is a rule that maps an input to a unique output. So in the previous examples, our inputs, so what do we put into the calculation or into the billing machine? It was how many hours. And then we got an output, which was how much should be charged. Each input should have only one possible output. We'll come back to that in a minute. We usually call the function f of x. So f bracket x, and what we say is f of x. It's a function of x. It changes with x. Okay. Sometimes it has another name. So you may come across g of x or h of x. They're just letters, okay, to say that this is a different function. G of x is different to f of x. Sometimes I've seen a p of x, where p represents profit and x would be the number of products sold. Okay, so just different names. The brackets here do not indicate multiplication. Okay, so we don't ever multiply f by x. Okay, it doesn't make sense to do that. And f of x does not enter into any calculations or manipulation of the function expression. So you're not moving f of x over or back the equal sign. Okay, it's just the name of the function and it tells you what the function depends on, which is x. So f of x equals 2x plus 3, for example. Okay, nothing ever crosses that equals. It's just saying the function of x, what changes with x, is 2x plus 3. Okay, and sometimes it's written with this slightly different notation, but we still say f of x, and this colon is used here. So it says the function takes x and it maps it onto, it gives an answer of 2x plus 3. Okay, so two different notations there meaning the same thing. So inputs and domain. An input is the number we put into the function. So for the electrician it was 2 for 2 hours or 3 for 3 hours. Usually it is the x value that we substitute in. It is the start value, okay, of our process, and the domain is the set of inputs for which a function is defined. Okay, we'll see what that means in a minute. Here's an example of something you might be asked to do. Draw the graph of the linear function f of x is 4x minus 3 in the domain minus 3 is less than or equal to x is less than or equal to 4, and x is a real number. So what's that? So a domain is the set of inputs. Okay, there's our domain, and we're given a range here. So from minus 3, that's what that says, to plus 4. Okay, and we'll see that in a minute. This is an instruction to draw the graph within the region of the x-axis from minus 3 up to 4. So it's asking you to use x values from minus 3 up to 4. All real numbers x between minus 3 and 4 should be included. Okay, this means the function will be continuous and shown by a continuous line. Okay, well that doesn't make much sense until we see it. Okay, so if you were to do this, what you would do is to take a number of values between minus 3 and plus 4. Okay, and you would input them into this function. So what does that mean? You would start with perhaps f of minus 3. What does it become? Okay, so the function tells you to multiply the minus 3 by 4. So 4 times your x, 4 times your input, 4 times minus 3, take away 3. 4 by minus 3 is minus 12, minus 3, and when you have minus 12 minus 3, the result is minus 15. Okay, and here you can see that in this table. When your x value or your input is minus 3, your output or your function value is minus 15, and you would do that for some more numbers. Usually we go up in ones, up as far as plus 4. Okay, and all these input numbers, they're known as our domain. Okay, and in actual fact all the numbers between, so a half and 1.1 and all of those, they could be included, but that would be too many calculations for the graph, okay, or for us. So what happens when we put this on a graph? Okay, well this is what it looks like. So on the x value, or on the x-axis, the horizontal, are our inputs, and on the y-axis or vertical axis we're going to label that f of x. Okay, so f of x appears on the y-axis, it's our outputs. So let's just check. So minus 3 on the input axis is here, and that gave us an output of minus 15. So that gives us this point here. Okay, and so on. Minus 2 from the table gave us minus 11, which is this one. Minus 1 from the table, there's minus 1, gave us minus 7. 0 gives 3, minus 3. 1 gives 1, that's that one there, because we've two different scales here, and so on. It gives us these points, but we're told all the real values should be included. So our function in that domain is the straight line from here to here. Okay, and our domain is from minus 3 to plus 4 It's the region of the graph that we're interested in. Okay, so a lot to take in. Okay, outputs and range. An output then is the number that comes out of the function. So if we have f of x is 4x minus 3, which we had previously, then 4 and 4 is the input. So here's our inputs. And if 4 is our input, okay, we saw already that when you calculate it, we should get the output f of x. So you here's another example of an input you use. So you put 4 into the function, and 4 times 4, so instead of 4 times x, it's going in here. Take away 3 gives me 16 minus 3, which gives me 13. So the function took 4 and it made it give an output of 13. Okay, and we can see that couple there, 4 on our as an input gives 13 as an output, or f of x, and it gives me this point here. Now, so the output is 13. On the graph, the outputs f of x are located on the y-axis, and the range is the actual output values of a function. Okay, the outputs from our given domain, so our function was defined in this area, and they gave us from minus 15 down to plus 13. This is our range. Okay, we had values. If I mark them on the f of x axis, beginning with minus 15 and going up as far as plus 13 in the specified domain. Okay, that's our range. So the range is the set of actual output values of a function. Remember, we're only looking at from this point up as far, from here up as far as here. Okay, and that's our range. And then the codomain is the name that's given to the set of all possible output values. So if we went outside minus 3 to 4 as inputs, what would be the possible output values? And you can see on the graph that the blue line would extend outside of our domain to plus infinity and minus infinity. So plus infinity on the f of x line to minus infinity. It will go on forever in both directions. So the codomain is the set of all possible. Now, firstly, we have some mathematical expressions that are not functions, okay, and some that are. So a function is a rule that maps an input to a unique output, okay. In the example of the electrician on slide 2, where we had the function b was 20t plus 50, a 2-hour job would always come to 90 euros. Okay, do the calculation again. Multiply 20 by 2 and add 50, you get 90. Like, it will always be 90. Okay, with that function. Why would it change? Okay, if you start coming up with bills of 110 for some people and 70 for others, there's something wrong. Okay, here's an example. A plumber charges 25 euro per hour's work, up to 6 hours a day. Beyond 6 hours he charges no extra. So here's a table to show his bill. So 25 euros per hour, so it's climbing up 1, 2, 3, 4, 5, 6. It's going 25, 50, 75, 100, 125, 150. But after that, for 7 hours he caps it at 150, and 8 hours 150. Okay, so his inputs are the number of hours, and that's our domain, and his outputs are the bills, okay, and that's our range. okay, from 25 to 150. And the question being really, is it still a function? So when you put in 1 hour into his billing system, do you always get 25? Yes. 2, you always get 50, 3, 75, 400, 5, 125, and 6, 150. You always get 150. Now if he does 7 hours today, the bill will be 150. If he does 7 hours tomorrow, the bill will still be 150. It won't change because he's made a rule, because he's made a function. And 7 hours always gives 150. Okay, 7 hours always gives that output. It doesn't change. And same for 8. Okay, so each input X should only have one output. Okay, so what we see here are diagrams, and our inputs are set A, and our outputs are set B. Okay, so they may be numbers, they may be not, it may be something else. Okay, so the first one it says is not a function, and what is the reason? It's because this input here sometimes gives you this result and sometimes gives you this result. Okay, doesn't always result in the same one output. Okay, so that is not a function. The second one now, let's track from each input A, it goes to just one output. So to check, you see, is there just one arrow coming from each blue dot? And there is. And we don't worry about the rest of it, okay? And so it is a function. Okay, this diagram shows a graph, okay, and it says it's not a function. Now, why is that? It's because the inputs on the x-axis here, so let's say this is x is, what's it look like there? Let's say 3.5. When you put 3.5 into the function, it's telling me that sometimes I get this answer and sometimes I get this answer. So it's telling me that there's two different answers for the one input, 3.5, and that's not possible. Okay, so this one is not a function. And to test a function on a graph, you can do this vertical line test. You can put your pencil down along the y-axis, okay, and bring your pencil across, and if at any stage it crosses the graph twice, well then it's not a function. Okay, so for example, a circle is not a function because if you use a vertical line, it can sometimes cross it twice. It fails the vertical line test. And now you do it. Check you've understood by doing the quiz and practice what you've learned by doing the written exercises. Here's a glossary.